afternoon. As Dr. Wabi said, my name is Lieutenant Colonel Eric Savickas, and I am an Army officer. I've been in the Army for a little over 20 years now, and today I'm going to talk about GPS technology and its applications in the military. Now, I'm not an expert on GPS technology, and I don't claim to know the science behind how the satellites are all in orbit and how everything pieces together. But what I do have by way of knowledge and experience is through my time in the military, I've seen a progression of the technology of how GPS has been used in different applications from the time I started until now, and even here at the university and how we use it, which I'll get into in a little bit. When I talk about GPS technology to my students here, you know, they seem to give the impression like, well, it's no big deal. It's what they've been seeing all along. They grew up with GPS technology, whether it be in a GPS device that was in, you know, their family's car or their car now, or nowadays everyone pretty much has some sort of a smartphone that has GPS technology built into it. When I was coming up in the military, and not that it was so long ago, but when I was coming up, it was all about maps and it was all about compasses to figure out how to get from one point to another, or how to determine where your current location is and do the general basic navigation stuff. So when GPS came on the scene, it was shocking. Not necessarily shocking, but it was a huge benefit, a huge increase in the ability for us to do what we needed to do in training or on the battlefield. Certainly we still teach and train on how to navigate with a compass and a map, and we do that here at the university now with the cadets in the ROTC program as well. But at some point we've moved beyond the map and the compass to the current technologies, and we've embraced them in the military, and we'll continue to embrace the GPS technology as we go. You can see here some of the points I want to cover during the brief this afternoon. I want to talk briefly about the history of GPS technology and how we got to where we are now. I want to talk about something called selective availability as it applies to the military and civilian uses of GPS technology. And then I'll get into a little bit more military-specific applications of GPS technology and how we use it on a daily basis. First, by way of overview, the Department of Defense and the United States Air Force developed GPS technology back in the 1960s. Originally, in actuality, it was the launch of the Sputnik satellite that allowed scientists to determine that, hey, wait a second, if we're used to navigating off the stars and other celestial bodies now, and we know how that whole math formula works, well, what's the difference between that, you know, celestial body and a man-made celestial body that's traveling in a geosynchronous orbit around the Earth? And you can do the same math calculation, and they determined if you can do it off of one satellite, then the technology is there to increase, once you increase other satellites, to have the whole Earth covered in a blanket, essentially, where we're at the point now where you can be standing on any point in the Earth and there's always 4 satellites or more visible to calculate your accurate position, and time is another factor that the GPS calculates. So we went from the 1960s and started developing what's called Navstar, which is what the military refers to and scientists refer to as our current GPS technology. Owned and operated by the United States government and free of charge to the public. So which is interesting to me because, you know, cell phone usage isn't free of charge. Satellite television isn't free of charge. Even electricity isn't free of charge. But this multi-billion-dollar capability designed by the United States and the Department of Defense, is free to anybody out there, not only in the United States, but all around the world. And even we've codified that in law, saying that the Department of Defense has to maintain the system so that it's available on a worldwide basis. And we have to not only maintain the system, but we have to protect the system so that if there's any threats or adversaries out there that want to do harm to the system, we have to defend it so that it remains available for civilian use. GPS consists of three components, pretty straightforward. There's the satellites that operate in space, the geosynchronous orbit that we talked about. There's the control systems. There's monitoring stations, antennas, and just a command and control system that's in Colorado. And you can see on the screen there where some of those are located. And then the user, using a GPS device, whether it's the one in your automobile or in your phone, that gets the signal and determines your location or whatever other means you're using GPS for. Back to the history again for a second. I already mentioned the 1960s, how scientists were determining the usage and the technology behind GPS, and then it went from there. The Navy started using it, using the first satellites that were put into orbit to determine location of ships at sea, and you could only do that at certain times during the day when those satellites were available. It went from there to another system to determine that you could determine time accurately through these satellite systems. And then the Navstar, which is our current system, the first elements of that system started going into orbit in 1989, and then the 24th one was launched in 1994. Now it's interesting, originally the entire intent of GPS was for military use. And that's what the technology was designed for. But Ronald Reagan determined back in 1983, after a Korean passenger jet was shot down over the Soviet Union after it strayed into its protected airspace, that, wait a second, we have this technology here, so we need to open it up for civilian use. Because it just benefits society as a whole if folks know where they are, and in this case an airliner would have known where it was and wouldn't have strayed into Soviet airspace. The Gulf War came in 1990, 1991 time frame, and we now had an actual real-world military use for GPS. And at the time, there were only 16 satellites in orbit, and you could only have accurate location data for 19 hours a day. Now, since then, we've achieved initial operational capability, which meant 24 satellites were in orbit, and then full operational capability after that in 1995, which is where we are today. Okay, there's something called selective availability, and I'm not sure if anyone is familiar or not, but originally when the capability was designed, it was designed for military uses, like I mentioned. And so because it was for military uses, the United States put a system in place where we degraded the location accuracy for civilian use. So if you bought a GPS device at the store at the time, you would be able to get within 100 meters accuracy. So from this room, if I was standing here and I had a GPS at the time, it would tell me I was somewhere around the building or even outside the building. That was the level of accuracy that the government was willing to give for civilian use. The military retained a 10-meter accuracy at the time. And to get that, all the military GPS devices had a cryptologic fill that had to go into the devices so that we could use it with that kind of accuracy. Now, President Clinton, he actually, back in the late 90s, but not until midnight on May 1st, 2000, was the determination made to change that availability so that everybody, not only military, could get the 10-meter accuracy, but everybody could. Now, the reason for that was because not only was technology improving, we were also improving in our ability to prevent adversaries from impacting our systems. And that was really one of the main reasons that we had that precise capability retained by the military, so that if somebody else out there had a jamming capability, we could still operate our systems. And now, even though it says 10 meters, we're probably, with technology nowadays, at a 1 meter accuracy. Now, that switch, if it is indeed a switch, in Colorado at the control station, can be turned at any time if the United States determines that it's our best national security interests or what have you, to make it so that the civilian population is degraded again for satellite uses. Now, even though this is a US system and it's a worldwide system and people use GPS around the world, other countries have developed similar technologies. The Soviet Union, or Russia now, has something called GLONASS. They have not nearly the same number of satellites available, so they have a limited capability with that. The European Union has another system as well, but this still is the gold standard for location technology, GPS technology around the world. Okay, as far as military uses, this is what we started with back in the early 1990s. This is what, and although I didn't deploy to the Gulf War, I was in ROTC at the time, this is what the soldiers deployed with. Now this system there, I should have put something that shows the relative size. It's probably about this wide and this tall. And it was either mounted on the dashboard of a vehicle, like a Humvee, or it was man-portable with batteries. Now the batteries themselves that went in this probably weigh, you know, about I want to say 2 pounds, 3 pounds maybe. They're pretty heavy, and they didn't last very long. And so that was actually something that made this system not as capable. It made it so that soldiers, even though they got the technology, they wanted to find a location from it, it made it hard to use.
Do you know what appeared on that screen? Like, was it like an arrow or like, you know, like...
Oh, and this?
Yeah, like
This had it was a digital readout, and it showed numbers. Basically on a map. What the military does on a map is they use the military grid reference system. It's basically similar to latitude and longitude, and you can determine through numbers, either 4, 6, or 8, or 10 digits, exactly where you are on the Earth at any given time. And you could do that with a map, and what this system did here was it read that number out on the screen. And then if you put waypoints in there, like you can in GPSs now. If you want to go from point A to point B, it read the direction out on there. And on the back side, or actually over here, is where you'd put that crypto fill in and made it so that the system was capable for military use. Bulky and not the best technology. Shortly thereafter, 1993 came out what this was called even though it's called SLGR, it was referred to as the Slugger. This is the plugger here, the Precision Lightweight GPS. It now operates on the secure fill for the military use only. And you can see here by way of size, you would put your hand in here and you would be able to use your thumb to push the buttons and do what you needed to do. And then this is the antenna, and that turned up, and you can see the relative size of that piece of equipment there. And just like we talked about on the other one, it gave your location digitally on the screen. That system there is still in use in the military, largely. It came in 1993. It's a ruggedized piece of equipment, so it's not going to break, and we still use it in a lot of units today. That one was replaced by the Dagger. So we went Slugger, Plugger, now Dagger. And now the Dagger is smaller, more capable, more lightweight, and easily carried. You know, the battery on this is about the length of this whole system. It goes in that big cap in the top, and comes down to about here. Now this is a normal, probably uses lithium batteries, and that's more capable. And you can see instead of just a digital readout with numbers and letters, you know, instead of an alphanumeric, you now have a map screen on there. That came in 2004, and again, between the plugger and the dagger, that's what we use currently. In the last couple years, the military and defense contractors have been designing the micro GPS device, which is smaller. It's got a touch screen now, and it's full color. So it gets to the capability now that we had from commercial off-the-shelf technologies with touch screens or even handheld GPS devices. Now the interesting thing though about all of these is that while the military does a great job and the defense industries do a great job of coming up with new technologies and developing those technologies into practical uses, in my experience at least, we are very slow and not responsive in our acquisition procedures to get the technologies to the force. So as a result, we are generally years behind in the technology by the time it gets in the hands of the soldiers. So most soldiers that I know carry some sort of a civilian GPS, because remember I mentioned back in 2000 when they said that we were going to turn off the selective availability, this has the same accuracy as that. So there's no difference now. So most soldiers I know carry something that's commercial off-the-shelf technology that they can go to the Best Buy and pick up and carry it in their gear with them. Now if the Department of Defense ever flipped that selective availability switch again, then those we'd be out of luck with, and we'd have to rely on what we get through the military. And I'm not saying the military equipment's bad. I'm just saying that sometimes your unit may only have one per squad of 9 people, and you may want one in case you get separated, you have that, or whatever various other reasons.
Soldiers are allowed to get something outside the gear.
Yes, and what the official policy is, at least in terms of GPS devices, is the government and the Department of Defense recognizes that many soldiers out there have their own GPSs, and they're authorized for use to determine your own personal location. But when it comes to determining location for precision-guided munitions and other things where it's whole units that are impacted and the ability for us to deliver munitions on a target, an enemy target, then we have to use the ones that have the higher technology in them and that are approved. Yes. Yes. So as we've gone through the years, we've gone past the point where we just use the GPS to determine location or waypoints for navigation, but we use the GPS technology now for lots of different applications. Just like in the civilian sector, there's tons of applications for GPS technology, and these are just a few here. We talk about positioning, we talk about navigation, but precision munitions. My background and my career field is as a field artillery officer. Field artillery are the cannons, like this one up here, that shoot high explosive projectiles, normally on a ballistic trajectory onto a target 10, 15, 20, 30, up to 50 kilometers away. Now, when I was coming up, we had to study the math and all the ballistics to determine what angle you would raise the tube to shoot, what the charge was to shoot it, and to get it to that target that you wanted to. Now we have systems where the projectile has a GPS in it, and it guides it to the target. And what I'm going to show you, we use this system now with the artillery called the Excalibur, and I'm going to show you a quick video here of just, it shows the accuracy that we're talking now with the Excalibur. Okay, maybe it's not. One second. So that was from 12 kilometers away. Almost 20 kilometers. All right, so you get the idea of that there. Now, just that was at probably at Aberdeen Proving Ground or somewhere where they were testing the system. Now, in terms of actual usage, I was deployed to Iraq in 2009 in one of my deployments, and just in its actual real-world use, my unit had the Excalibur fielded to us. We saw through an unmanned aerial vehicle that was flying out over in an area that we wanted to look at, there was a suspicious looking vehicle. It was a pickup truck, and it was probably, I would say, 12 kilometers away. Suspicious looking pickup truck, two individuals, they were getting out of the truck and they were doing digging around a road. Now at the time, that meant that there were these probably improvised explosive devices that they were putting in the road that were causing a lot of harm to our soldiers there. So we had enough evidence through that unmanned aerial vehicle to engage it, and we chose to use the Excalibur round with an artillery system, fired it, and we watched over the video that was in the unmanned aerial vehicle that round went right into the window of the truck, the driver's side window of the truck, and a very similar reaction to that.
The device for direction would be in the piece that includes or in the...
It's in the round itself. So I don't have the price off the top of my head, but each round is pretty expensive. But if it prevents more casualties, then for the greater good, it's worth it.
The crosshair would be transmitted into the cannon itself?
No, there's a small device that before we put it in the cannon, it's a little handheld computer that you enter the location, the 8-digit or 10-digit location in there. You touch it to the fuse on the round, and it transmits the data, and then that round itself, the projectile, knows where it's going. And as soon as you fire it, no, it directs itself.
So you just send it...
You just shoot it in the direction, and it will course correct as it goes. The other thing that the military has been doing with GPS technology, it's not just for precision guided munitions and destruction. We use it for humanitarian aid and assistance, and even resupplies for our own forces. I'd like to show you a quick clip here of how we use the technology in airdropping cargo. Okay. Apparently my technology of computers isn't as strong. Give it another shot here.
U.S. forces completed a high-altitude aerial delivery mission to combat Outpost Herrera in the eastern mountains of Afghanistan. Army riggers worked alongside airmen at Kandahar Airfield, building and loading a C-130 Hercules with supply bundles equipped with Joint Precision Airdrop Systems, or JPADS.
JPAD systems is designed to basically get into smaller areas. This particular model has terrain avoidance. It's a mapping system, 10-digit grid coordinate. Say the Air Force is in flight and they get communication from the ground force that there's hostiles in the area. The Air Force can change the coordinates to get to a different DZ that's more secure.
So sometimes it will come down. Somebody needs this, it's up to us to get it to them. So sometimes as far as their fight goes out there, it starts with us.
JPADS use the same global positioning system, or GPS guidance, that enables precision strikes from smart bombs. Now it steers airdrop cargo directly to the drop zone.
This mission is a little more complicated with the fact that we got the GPS guided. That helps us be safer, and also it's more accurate for the guys on the ground.
It's a good system. It allows the aircrew and aircraft to use standoff capability. We were able to deliver our combat ordnance to our men and women on the front lines, basically put it right on the doorstep.
The JPADS accurately directed the cargo containing 18,000 pounds of fuel to the troops down below.
I was very impressed that they were able to drop those bundles from 17,000 feet and be able to hit their mark that way.
Seeing it firsthand was quite an experience itself. So, but overall, like I said, I think it went well. You know, probably one of the main ingredients for all our missions is having the fuel, so it's great.
I think it worked out really well. As soon as the bundle started dropping, we were able to get in our vehicles, head down to the drop zone, and we got all the items recovered.
The ability to be able to drop in the fuel like this, it's definitely going to keep us operational through the winter.
For AFSET News, I'm Staff Sergeant Josie Anderson.
Now, I personally don't really know the technology it uses to course correct and to steer it into the drop zone, but that technology is there, and you can see how, at least now in the now in 2013 and a couple years before, we were using this stuff to increase the efficiency of the troops and the survivability of the troops in the field in order to accomplish the mission. Now, to bring it full circle, we had the global war on terrorism, and now back here at Eastern Illinois University, I just want to kind of conclude with how we're using technology here for our group of cadets in ROTC. We still teach map and compass navigation to the cadets. And we send them out on a land navigation course where they have to apply their knowledge of map and compass navigation in a practical environment. And so what I determined as their primary instructor was it's hard for them if they make a mistake on the course and they get off course or they don't find the waypoints that they need to find, it's hard for them to go back and think about, well, what did I do wrong? And so I knew the technology existed out there through GPS to help use it as a training tool. So we contacted Garmin, the Garmin company, and they helped us get for the university here some GPS tracking devices. We take this GPS antenna or tracker and we put it in their gear with the antenna. And then we track on a handheld device or in real time on a laptop where the cadets are at all times. Now this does two things for us. Number one, it's a safety mechanism. If we get a cadet out there on the course and they get lost and they don't find their way and then darkness starts coming, or like today it's cold outside, we can go on the handheld or go on the computer and determine exactly where that cadet is and prevent an even worse situation from happening. But it's also a training tool. I can go back, for every cadet that comes back in from the land navigation course, on the computer, I can hit rewind and show them what I guess what they call a snail trail. It shows exactly where that cadet went. So if that cadet is using his compass or her compass and they're drifting left every time, I can show that on the computer screen and we can use it as a training tool. Now the interesting thing about this technology is now we're just testing this right now, but when we contacted Garmin, they said that the best thing to use is this is actually a hunting dog device. These go on dog collars, and this is to make sure that your dog doesn't get lost. And you know, we took them off the collars obviously, but if you look out in the market for other commercial applications, most of them you'd have to pay a monthly fee for, or use a SIM card from a cell phone or something like that. So this was the most efficient and cheapest method we could get with the money that we had available to implement a GPS technology into our training. And so far it's worked fantastic. And you know, the cadets don't mind that it's made for dogs. They just see it as a great training tool. So at this point, the references are listed there on the copy of the slides if you want to go back. But that's pretty much it.